we have our own Nalini speaking on encryption and enterprise data center. Nalini is the CEO of Insight Product. She has been involved as a CEO and CTO for multiple startups. In IETF, she started her involvement with performance metrics and measurement. I was really impressed by her, a lot of effort that she put in the mentoring effort as well. So we're bringing in new people into IETF, and that's how my interaction with her at IETF kind of started and took off, and I was really impressed with the effort that she has put in. And since then, she has mentored us here in India, lots of us, on how to build a whole community here, and we are very thankful for her guidance. And let's hear from her from the enterprise and data center space. And she was doing a lot of work with EDCO and other consortium where she's representing the point of view of the enterprise data center folks at the IETF, which sometimes might be where the enterprise and folks are a little underrepresented. So she's a strong voice for their point of view. So let's welcome Nalini.
Thanks so much, Drew. Okay, so let me give you a little background on this. What I'm going to talk about has been kind of a controversial topic at the IETF, but it has been very instructive. To me, it's like you learn so much by going through basically armed warfare. And that's what it has been. But I'll tell you the history, because it's been about a year since we came to a resolution for one part of it, and the other parts continue. But let me give you a little history of why I'm doing all this. I have been working with enterprises. By enterprises, I mean the large brick and mortar traditional industries. For about 30 years. I mean like the large oil companies, health insurance companies, the banks, governments, people like that. Those are the traditional industries. Those are not your Googles and your Apples and your Netflix. These are the things, these are the companies that basically keep the economy and the governments of the world running. But you know what? At the IETF, I can count how many of them are there on the fingers of one hand. And three of them are with me. So, this is a story of armed warfare. And that is what happens at the IETF sometimes. But now that about a year has passed, I'm sitting back and thinking about what happened. What happened from our point of view, what happened on the other point of view, and how did we get to this place? Because sometimes, I know somebody told me one time, when you have an argument within your family, let's say with your spouse or even your mother or your children, it's like you have to think, what part of it was I responsible for? What was it that I did? I mean, you're going to go on together, but you don't want to keep repeating the same thing over and over again. So it's good if you can understand the other point of view, because you're all going to be doing this for a long time. And one of the other things too, I was at a meeting last week in Bangalore, where actually one of the things Vinayak said was the difference between an engineer and a CTO is CTO understands context. And so if that's what I'm going to try to set for you now, is the context within which one of the most interesting conflicts in the IETF is happening. So let's see what it is. And there's a number of these. When you hear Fred talk later, he'll tell you about some of the principles of the IETF. One of the principles is engaged here too. What is happening is that each side has a fundamentally different concept of what the problem is, what the future looks like, what the use cases are, and all of it. And neither side is wrong. It's a fundamental difference. For example, it's like there's a difference between ease of use and flexibility versus security. You know, there's always these fundamental conflicts, and I'm going to talk to you about one such conflict. So that is really the story of this little endeavor. We'll talk to you about the good news at the end. There is good news at the end. It was not all trench warfare. Both things started working at the end. And sometimes when both sides are right, there's not a good solution. There's only the least bad solution. And as engineers, we don't like that, but sometimes that's all there is. As I say, as I get into the technical details, you'll see what I mean. For those of you who are at the IETF, you will see that the story continues. This is going to be a story which is not finished for the next probably 5-10 years. And actually, there was a meeting to discuss this very issue in Washington, D.C. about a month ago. And I can't divulge the details for a lot of reasons, but there will be something coming out publicly about this from people who are way above my pay grade. Let me just put it that way. Yeah. So, okay? So, what is the problem? There are people who believe in privacy at the IETF, and there are people who want to do network management. Not that the network management people don't want privacy, and not that the privacy people don't want network management. It's just what's better. So if you look at it from a very, very high perspective, take a 10,000 foot view. Why do we do encryption? Well, what is encryption? You take clear text, you put something around it, and you make it so people can't read it. You're trying to hide something. Well, who are you trying to hide stuff from? Well, there's bad people. Bad people who want to do a lot of things. They want to hack into you, steal your credit cards. So fundamentally, everybody agrees. We want to encrypt things, and there's bad people. What they don't agree on is exactly who the bad people are. And yeah, that's where we get into it. And what is the stuff that you're trying to hide? Because it ends up that some of the stuff that people want to hide is exactly the stuff we need for network management. So how we do all this? So that's the part of the tussle. And exactly what do you mean? The devil is in the details. How exactly are you going to do all this? I mean, it's all great to say, yeah, we want to go to the moon. Sure. Yeah, everybody wants to go to the moon. How are you going to do all this? Yeah, that's been the problem. So let's get down to it. So this has been a lot of, blah, blah, blah in the upper air. So let's talk about the realities of what am I talking about. We're talking about 3 different protocols that are impacted right now. TLS, which is Transport Layer Security, it is the most widely used security protocol in the world, period, right? TLS, that's it. And a fair amount of this, I'll go into the details of the saga at TLS. The good news, I am going to say there is good news. Good news comes in with the fight over DNS over HTTPS. QUIC is still out the jury's out on that. But as I say, there's some good news. So what am I talking about? There's those 3 protocols, and there's 2 different points of view on this. Remember I said there's the privacy advocates and the network management people? The network management people that I'm going to talk about, that I can speak to, as I say, in living color, are the enterprises. So I'll tell you a little story about how the enterprises got involved in all this. I've been coming to the IETF for a while. And I used to go back and tell my enterprise, the people that I talked to, my customers, the large brick and mortars, and I'd say, you guys, there's a party going on. All these decisions are being made. Google is sending 50 people. Huawei is sending 50 people. These decisions are being made. They impact you. You should be there. And of course, and you can guess what they said to me. Oh, you sure talk a lot, Nalini. Yeah, you go, and you tell us what happened. Because the other thing is, where are these meetings? They're in Prague, Hawaii, Singapore? Like, really? Yeah, okay. Just tell us what happened, but don't talk too long. I'm like, okay. When I told them about what was going on with TLS 1.3, it was on a Thursday, as I recall. There were about 20, 30 phone calls over that weekend. By Monday morning, they said, you go with her to Germany. You find out what the heck's going on over there. And that started a lot of stuff. So, okay. So what happened? What happened is there was a one-line change in the TLS 1.3 protocol. And that one-line change was to remove support for the RSA and static Diffie-Hellman protocol, or key exchanges. You're like, and this is it. The one-line change that was in draft 02, and I believe it was at draft 27 or something like that by the time it finished. This one-line change was going to mean millions of dollars of change in topology for just about every single brick and mortar enterprise. That's why they're like, all of a sudden they found $4,000 to go to the IETF. So I'll explain to you what this is and what happened, okay? So this is one from Nancy Kamwingett at Cisco. What she said is that if you get rid of RSA and static Diffie-Hellman, you can't put that key into the middle boxes, and if you don't have that to put into the middle boxes, all network monitoring, troubleshooting, compliance, all of that is going to be impacted. So let me explain again how this is working. What enterprises do is they take that private key and they put it into the middle boxes. And that allows the middle boxes to decrypt. It allows them to decrypt the data so they can do things like IDS, IPS, firewall, all that kind of stuff. And you need that because you can't do it on an encrypted packet. You don't know anything that's an encrypted packet, okay? So let me give you the point of view of the privacy advocates and the security experts. Again, I'm not saying they're wrong. They're not wrong to want to try to do this. It was right to take away RSA, okay? So why? Why remove RSA? Well, RSA depends on something called prime number factorization. Essentially, prime number factorization is given a one number, you need all the prime number factors of that number. For example, if I give you 15, what are the two prime, this one happens to have two prime numbers, it could have three. What are the two prime numbers that make up 15? 3 and 5. 3 and 5. You multiply this, you get 15. The problem with prime number factorization is there's no algorithm for it. Hold on to that thought. There's no algorithm. It has to be done by brute force. And so that's what RSA relies on, is that you have to do it by brute force. And there's a couple of other things. Having said that, there's a few things now that allow us to break RSA, okay? So there's robot, return of Blankenbacher's Oracle threat. So what you can do is that there's a vulnerability where you can use this threat and grab the private key. So that has now come back. Quantum computing. One of the reasons that we need quantum computing is because what quantum computing can do is allow us to do things like prime number factorization, okay? So there is a guy, there's a guy coming up, and Peter Shor, he's a guy at MIT, and he developed an algorithm. It's called Shor's algorithm. And what he said is that with a quantum computer, I can factor prime numbers. Problem was, he didn't have a quantum computer. Along comes this guy, Isaac Chang, and he had a quantum computer. He figured out how to do it. They were both at MIT, and I presume in the faculty lounge, they were talking to each other, and they're like, hey, let's do this, all right? So now, pretty soon, we started moving it along here. We got prime number factorization, and pretty soon, we're starting to factor things like 15 and 23, and keep on going like that. So we can do very small numbers right now, very small numbers, but we're going to get to the point where quantum computers actually can do extremely large numbers of factors very quickly. But the better point is, why do I need to worry about quantum computers, prime number factorization, and all of that? A number of government agencies who have 3- and 4-letter acronyms, and I won't mention them, decided, this is too complicated. You know what I'm going to do? I'm going to steal them. I'm going to steal the private keys. I am smart. I do not need to do this mathematics. So, okay? This is a diagram. One of the things that happened along this trip here is there was a guy who revealed all these secrets that the NSA was doing. Oh, what was his name here? Starts with an E. Oh, yeah, Edward Snowden. Edward Snowden. He divulged a lot of information, including this slide from GCHQ, saying that they were going in and stealing private keys for a lot of different cell phones and encryption. Once you got the private key, you got it. You're fine. Now, do not, I am not against law enforcement by any stretch of the imagination. You know, I'm a mother, okay? Okay, I'm in mothers against drunk driving, mothers against this, mothers against that. I want my children protected. I want law enforcement. I do not think it's a great idea to bulk data capture everybody's thing who did nothing wrong and start looking at it. If you have a valid permit, valid warrant, go. Take it. I help you. I'll be the first one to help you. If you have a valid warrant. Okay. That was not what was done. So anyway, so for a lot of reasons, people wanted to take away RSA. Problem was, back at the large enterprises, they use RSA. They use RSA keys. They put it into firewalls, you know, everything else, all these appliances. You know the pictures that the VMware guys showed of everything they're going to take away, that before picture? Yeah, that's my enterprises. That's what we do. That's what we are. We're the before picture of everything. You know? Yeah. We need all that stuff. You know, we need these. We do out-of-band decryption. The other thing that people are going to say, why do you need to do out-of-band decryption? I'll explain to you why. I'll explain to you. They're not as dolts as you might think. They're not that stupid. They are stupid, but not that stupid. Okay? So, all right. So who are these people? Who are these people? This is the global Fortune 500. Walmart, Royal Dutch Shell, China Petroleum, Aramco. I mean, I used to work for Chevron, which is part of our, you know, they had, I think, quarter share of Aramco. You know, I've talked to guys from Walmart. You know, these people are not stupid. One, they didn't get to be that stupid to make that much money, okay? They can't be that stupid. So this is the underpinnings of our economies, okay? Also the healthcare insurance industries. In the United States, we have the Blue Cross companies. It's the largest healthcare insurance consortium in the country. It's like just like trillions of dollars of premiums. I was on the team that helped design their transition to IPv6, which never happened, by the way, but we put a lot of plans into the place for that. So these people they're large, they have huge networks that impact everybody. Also the government, federal, local, state, law enforcement, schools, hospitals, and it's getting so complex. I was actually talking to some law enforcement people at the federal level, and they said, it's so all this stuff is so complicated. Every time anything happens, we get called. For every time there's a mass shooting, for example, every time there's a mass shooting, immediately it has to be federalized. It's so complicated now, so it's very tricky. What are they doing? They're doing this kind of stuff. Lots of middle boxes. Middle boxes serve a function. They are not just people. They don't just buy these things because they don't do anything. The Department of Defense has a mandate for doing deep packet inspection on their networks. I mean, I can look up the regulation for you. But that in order to do stuff like this, what people are using is RSA private keys. If you don't have it, it gets very difficult. And I'll tell you the end of the story and what people are doing. But I'm telling you the state of events right now. This is what people are doing. This is what people are doing. Okay. So, what's part of the tussle? This is a quote, almost exactly, from a conversation that I had on this topic with somebody in the IETF leadership. And, as I said, I'll let the heat and steam come out of my ears. And what they said was, some of us who've been at the IETF for a long time, we think that having smart endpoints and a dumb network, that is the true architecture. It's the end-to-end principle, They think that is the right way to do things. And I'm not saying they're wrong. I'm not saying they're wrong. That is certainly one point of view, is to have smart endpoints and a dumb network. Versus, this is unsustainable. It leads to an unsustainable trajectory to ever more complex endpoints and network functions. So that's what you're going to do? You all know, if you're programming and you try to squish 5,000 functions into one piece of code, that's going to be one piece of spaghetti code, right? One piece of, even if you do microservice, all of it. Why do you have subroutines? Why do you have microservices? You have to start putting stuff in different places. Not to mention, if the endpoint is compromised, end of story, right? End of story. You need to have checks and balances. As I say, this is the heart. These two slides. That is the heart of the tussle. Again, it's a different viewpoint on what the problem set is, what the use cases are, and what the likely future is. And both sides have a point of view. So, let's talk about the world of the enterprise. And I'm going to talk about the large brick and mortars in the United States, because that has been my life for the last 30 years. And they suffer from what I'm going to call first mover disadvantage. They started computerizing very, very early, in the 60s and 70s. And some of the stuff that Fred talked about, some of those networks that he said disappeared, oh no, they haven't disappeared. They're still alive and well in some of these places. I'm going to tell you that. I know some cities. There's one city I know, and I'm not going to say who it is, but it is one of the 5 most important cities of the world. They're running this protocol that was developed in the 1970s, because they were asking me, did I know any consultants who could help them transition? And I'm like, I don't know anybody who even knows that protocol. I'm sorry. you know? And what the problem is when they started computerizing, you know, what are you going to do? Are you going to start computerizing these no-name functions that you don't need? No, it's the core business functions they started computerizing first. That was the first programs that was written in the 1970s. Why did Y2K happen? What was the point of Y2K? Is you had a 2-digit year. If you're in the 1970s, you're not thinking about the year 2000. That's 30 years away. You're thinking, my program, who's going to be running my program 30 years from now? What do I care? 2-year date field. Two-digit date field. What do I care? Yeah, well, 30 years later, it was still being run. That's what happened. And some things, as I said, I used to work for an oil company. It costs $1 million. You dig a dry well, you dig a hole in the ground to look for oil, and there's no oil at the bottom of it. That's a dry well. It costs $1 million per dry hole to do that. One of the first things that they started computerizing is the modeling around how not to have dry holes. And so those are very early core business functions that were done, written in the early 70s. And the next thing that happened is, if it ain't broke, don't fix it. Don't touch it, in fact. Because you got all this other stuff. You got the pressures of business coming up. You got cell phones. You got this, that, World Wide Web, God knows what all. VMware announces a new product. You know, it's like, Jesus, you know, I got no time to rewrite that application that's working just fine. Don't touch it. And besides, at that point, any of the programmers who knew how that thing worked, what happened to them? Long gone. Long gone. In fact, sometimes source code is lost. I do not think that I am talking about, they are losers, but about some people who are not making money. These are people who are in the Fortune 500, some of them maybe in the Fortune 50 that I'm talking about. And they will never say it to you, they will never admit it to your face. That is exactly the situation that they're in. So, now this is a direct quote, almost, from a major US government agency. And he said, I was talking to him about converting to IPv6, because that's another thing, I'm a big fanatic. I'm like, you know, go around yammering to everybody. Fred Baker wrote this IPv6 protocol, and we got to all go to it. And he's like, you got rocks in your head. Our core application was written in the 70s. You think I'm going to rewrite that for V6? You got another thing coming. Because the other problem is, government agencies serve a function, generally, you know? And they don't just exist to take bribes or something like that. Like, for example, the Internal Revenue Service, they're supposed to collect taxes. So we want them to collect taxes. This particular government agency was in the newspapers all the time for not being able to do its core function. I'm not going to say who it is, again. But if they're supposed to collect taxes, I want them to focus on collecting taxes and not rewriting the application. That works. So then I'm like, yeah, cool, very cool. Yeah, don't convert. But this is reality. This is the reality of where we're at. As I say, a lot of these people are the before slide in the VMware's picture and Fred's. We're the before picture. And this is not a small percentage. There's a huge market opportunity for people, but this is the reality of people. So, there's another problem here, is, let's talk about bugs. Now, how many of you guys are developers or have written code? A lot of people. All right. So now, how many of you have a completely bug-free program?
We don't charge for the bugs.
All right. Okay. So imagine that you have a program with 100 bugs, and it takes 100 units to find all the bugs. So there's diminishing returns, right? So you find, So spend 40 units and you're gonna find the first 70 bugs. You find the first 70. You do some more, spend 30 units, and you're gonna find 20 more. So now you're up to about 90 bugs found. You're up to 90 bugs found. The next 10 bugs are gonna take a lot more effort, and then what happens? The marketing guy, the product manager comes running over to your desk and he's like, stop it. Just ship the product. Get it out there. We need some revenue, right? Send it out to QA. Okay, no, yeah, ship it, right? That's exactly what happens. I used to actually, I used to write commercial products. I still do. But I used to write them for somebody other than me. So, I'm sitting there and then the guy's going, ship it. And I'm like, cool, very cool. So we got lots of code out there that's still got bugs in it. So what has software in it? Do routers have bugs? Has software? Routers have software. There's tons of, everything's got software in it too. So we got all kinds of network equipment, all kinds of applications that still has some level of bugs in it. And the level of bugs that they have are the hard ones. They're the tricky ones that you only get intermittently or under certain conditions or in conditions of scale, right? That's the kind of bugs you have out there. So, now, imagine you're an enterprise. So, okay, imagine that you're Chevron, for example. I know them, I used to work for them. Huge oil company. We got lots of big networks. Our own microwave network, this, that, and the other thing. Huge scale. So, okay, so I'm solving problems. And if there's, if I have 100 problems, the first 40 units is going to find maybe the first 70. In fact, the easiest ones is what you say is, what was the last thing that you changed? Yeah, back it out. That's probably exactly what caused it, okay? And easily, you find a bunch of them. Next 30 units, you find some more. So then you've got these last 10 problems. These last 10 problems are probably the exact same problems that we had on the first page, right? Only under certain conditions of extreme stress are you going to get something, these kind of bugs. And what you need to do for these is to do packet decryption. You actually need to look at the packet to solve these. So I'm going to talk to you about a particular scenario too. And we'll start looking at packets. That's my life. My life is looking at packet traces and decrypting them. So, a lot of this enterprise data is stored, it's stored in these big IBM mainframes. These IBM mainframes that were started in the late 60s, early 70s, these are still storing something like north of 90% of the Fortune 500 core business data is on IBM mainframes. And this is kind of a typical topology of what it looks like. So this happened to be, again, it's a major city government of the United States, and they had law enforcement. Law enforcement was out there. I think this one, they might have been given tickets or something. So you got these people with, the meter maids or meter people with their cell phones, and they're trying to give tickets. They VPN into a server, goes through a couple of routers, so you got VPNs on either end, comes in, and then into an IBM mainframe at the end. And so we'll go through, and I'll tell you why we need some of the stuff that QUIC is hiding. But take this scenario and see, when there are serious problems, we need to decrypt. And I'll show you what I mean. So here's a TLS-12 to Google. And do we have a, yes. Is this the one that's yeah. So you can see right here, this is TLS-12. You can see stuff, all this stuff comes out, it's all encrypted. It shows up as application data. And so what I can do is I can put in something, the SSL keylog file. I'll show you this because it's easy to demonstrate on the endpoint. I put in SSL keylog file. This is in essence the RSA private key. I mean, you can think of it as a kind of a stand-in for that. So I do that, I stick it in there, and then lo and behold, I can see exactly what's going on. So if I can see this, then I'm like, okay, I can click into the packet and I can see exactly what's going on. I can start solving the problem. So this is what I need to do. When I got one of these really tricky problems, I need to see what's in the packet. Then I can start doing it. So, and you can do this for TLS 1.3 as well, but only at the end point. Only at the end point. There's more data that's needed. I mean, there's more key parameters that are needed, but you can do that. And as I say, I got plenty of traces and I can do it. The problem is, if I have, say 1 million endpoints, and some of them are business partners going God knows where, you tell me how I'm going to do this at the endpoint. I can't do it at any endpoint. I need to do it in the middle. That's why people have middle boxes. They have big packet capture devices. They put in key structures. People are not idiots for saying that just endpoint detection, endpoint monitoring doesn't work. You see an ISP. If you're an ISP, are you going to monitor at every endpoint? You can't. You don't even own the endpoint. You have to monitor in the middle. So this is one of the big problems. That's why you can say, see, this whole struggle really went on for about a year. It was pretty ugly. It was pretty bloody. I mean, there's people who still really won't talk to me. I don't think, I mean, it's like, it's a point of view, right? I mean, everybody's got a point of view. I'm not saying they're wrong for wanting what they want, but we're not wrong either, but the moral of the story really is we need to do a transition. There needs to be an escape hatch. There needs to be a way to get from one to the other. So as I say, I'll talk about how things are starting to happen, okay? So this is a good story. The similar story happened with DNS over HTTPS. So I had a conversation with one of my friends. He works for a Fortune 50 company. So I told him, you know what? People are going to start doing DNS. It's going to start going over an HTTPS query. And so it's going to be encrypted. You won't see what it is. It's going to be resolved maybe at, I don't know, Mozilla, Cloudflare, God knows who, somewhere that you don't own. They're going to see every single thing that your organization does and the rate at which you do it. If you're spying on your competition, they're going to see everything. You know what DNS shows. It shows you everything. And it's going to be not you that does it. It's going to be somebody else. And he said, really? That's going to happen? Oh, whoa. How do I stop this? This is not happening. Okay? So great. And there's actually a question asked in the House of Lords about this in the UK. They're like, really? The Internet Engineering Task Force is doing something called DNS over HTTPS? What is this? So, but there's a good story. There's a good story at the end. Mozilla announced that they're going to respect enterprise configurations and allow bypass. So they're going to see what enterprises are doing, and if there is a setup that's already done, they won't do their DNS over HTTPS. They'll follow what the enterprise wants to do. This, I think, is a real win. This feels good. It feels good. It's not perfect. I mean, there's some technical details that need to be worked out. But I think if we present a point of view and people say, sure, yeah, you have a valid use case and we'll work with it, that's good. But yeah, so this is what I say. There's good news at the end. That felt really good. There's stuff going on with QUIC, which is not resolved yet. So I'll tell you what the problem with QUIC is. What is QUIC? It's going to be a new transport layer protocol, equivalent to TCP and UDP. There's a lot of reasons why it's coming out. They're not wrong to want it. I totally get why they want it. It'll replace HTTP. It was originally from Google. And the reason people want it is OSSification. The internet is moving rapidly from 2000 to 2001. What that means is that you really can't do packets. You can't do a transport that's other than TCP or UDP. You try doing DCMP, SCTP, everybody just drops it. You know, stack developers don't want to write it. And if you start trying to do new functions on the TCP, you can't, because you've got so much equipment out there that won't support it. It's ossification. And NATs rewrite options, you have IDS, IPS, you have all kinds of devices. Again, if they're not wrong, that, you know, to want to try to evolve protocols. In fact, you know what? This ossification with all this old equipment, well, that sounds a whole lot like what happens at enterprises. That's why enterprises can't move, because they got all kind of old equipment that you still got to maintain. It's just, we have to figure out how to work with this. Because this particular problem, in this case, what was happening is the guy has his cell phone, he's trying to write a ticket for some scofflaw who's been parking for 3 hours in a 1 hour parking zone, but his connection drops, and it keeps dropping, and so he's calling support, and when you look at the packet trace, it looks like it's coming from the original source address, that the source address is sending a reset. And the guys in the source, they're like, no, I didn't send that. I'm not doing anything. It's not me. This literally went on for weeks. And they finally decided to blow for some consulting, and they called me. And what it turned out is that one of the VPN endpoints was spoofing the source address and sending the TCP reset. The only reason I knew that is there's another field. It happens to be the IPID field. That is, as a long story, I can show you the traces if you want. I can tell by one of the other packet header fields that it did not come from the source, but it came from something in the middle. And it needed, but the point is you need to go right inside the packet headers in order to see it. If QUIC starts encrypting these layer 3 headers, I'm dead. I don't know if the source sent it or one of the people in the middle sent it. The problem doesn't just go on for weeks, it goes on for months. Because if somebody tells you that you got a problem, what's your first reaction? Not my problem. I didn't do this. His source did it. All the VPN guys were like, no, I didn't know. He sent it. And until I showed them the packet, and then all of a sudden they're like, oh, maybe I did that. Yeah, you know, so you have to show proof. So this is really the elephant in the room for a lot of things, is the enterprises who are not at the IETF and who are not adopting these protocols and who are having a lot of problems. Like, I mean, IPv6 comes readily to mind, right? I think IPv6 adoption at large enterprises is something probably south of 10%. Yeah, and that's high, I'd say, on their internal networks. I'd say of the Fortune 500, probably 50% have their web server enabled, but a lot of them are doing it using these translation boxes, you know, yeah. So, but on their internal network, why should I do it? Why want to get, you know, what am I going to get? Because a lot of them also are sitting on these huge Class B addresses. That they got a million years ago. I got plenty of addresses. I don't need to switch for anything. I got lots of addresses. So, what we need to do, I think, is be better at transitions. I think that's one thing we do quite badly at the IETF. I'll show you something. I took my daughter to get a new iPhone, and after I had my heart attack about how much it cost, I'm like, okay, sure. So what they said is, like, if you want to take your apps from one to the other, you just hold them up, just right next to each other, and blammo spammo. And in like 2 minutes, she had all her old stuff on the new phone. It was amazing. And the guy said, you know, this used to take 2 hours. We used to have people lined up, you know, for support and for help with doing that. They were lined up outside the door to just to transfer apps from one to the other. This is sweet. What we need to do is make it easy to do transitions from one protocol to the next. To go from IPv4 to IPv6 should be easy. To go from TLS 1.2 to TLS 1.3 should not cost me $5 million. Is that too much to ask? I think it is. No, I know. It's not, again, that's, in the ideal world, that's what we would try to do. It's, again, this is Nalini's opinion. And as I say, I do not know how many backers I have, probably 0. But that's what I think that we need to do. Because I think that would make, it would make a lot of people's life easier, including developers of new protocols, because they would see actual adoption. So, let's talk about the future, which is coming. This is even more into the future. Now we're probably 5-10 years out into the future. But that's what we're writing standards for. And this is an interesting thing. The future is already here. It's just, not everywhere. But one of the things people are working on is stuff like this. This is a little company called kernel.co. And what they're doing is they implant chips into your hippocampus, and you can download all your memories onto that chip. And you can see it. You can see, like, if you have Alzheimer's, something like that, you can get access back to your memories. Or even, as I get older, I would like, sure, I forget things more. I'd like, sure, if I was like, what was that thing I did? Yeah, great. Where did I pick my keys? Sure, that'd be great. Problem though, who else has access to that memory? Where is it going to be stored? And a lot of people, it's going to be stored in the cloud. Really? Stored in the cloud? Who has access to that? What's the security mechanisms? And are you going to do end-to-end control on something like this on a chip embedded there? Really? This is what we're doing? Is you got firewalls inside your head? Come on, man. So this, what are we looking at here? So this is going to be interesting, where we're going in the future. In a few years, then we should have these guys, the biotech guys, the nanotech folks, coming into the IETF. Should be some interesting conversations. So, okay, questions? Uh-oh, here comes Mohit. Here comes trouble.
Hi, this is Mohit from Ericsson. So, I have no horses in this race and I don't have any opinions on either side. But to me it seems like from my participation at the IETF in the last four years, I've been going to all IETFs. It seems that people who are on the privacy side of the argument seem to be winning more of the battles than the enterprise side. And as a neutral observer, it seems to me the reason for this, and I think there are legitimate use cases on the enterprise side. But the reason I feel that the privacy folks are winning more of the battles is because the other side keeps shifting the goalpost. So at some point we say, yes, the enterprise wants to monitor its employees, which maybe is a legitimate use case, but then during your presentation you also said we can't monitor the endpoints because there could be 1 million endpoints and ISP wants to monitor. So maybe I'm fine with and I'm not saying like I personally am fine with it, but some people might be fine if their employer is monitoring the traffic while they are at their workplace, but they may not be fine that an ISP with millions of subscribers is doing the same monitoring. So perhaps I feel that it would help the case if we like stick with one use case and say this is what we are trying to solve, rather than saying like we want to support monitoring for ISPs, for enterprises, for whatnot.
No, you're totally right. You're totally right. I think between okay, so I'm going to throw something else in here too. There's kind of 3 overlapping things, and we share certain things. There's the traditional brick and mortar enterprises, the banks, oil companies, and so on. Then you have the ISPs, and we share certain things. Then you have something which has not gotten talked about, law enforcement. There's the law enforcement use case. And again, there's certain things we share and certain things we do not share. And yes, you're totally right. You're totally right. What has happened is that because there's so few of us, we've had to make some marriages of convenience with the ISPs, you know, for this point of view. Let me take you to MLS, for example, the case of MLS, message layer security. That's basically all the messaging apps, you know, that's the whole transport about that. And they're totally okay. Because if there's text messages and so that, I'm like, okay, we will be a third-party, transparent observer of the conversation. I'm your bank, and I'm going to tell you, I am on this conversation, I am monitoring this conversation, I will identify myself that I am on this, so you know what everybody knows. And they say the group is totally fine with that. If you're, for example, there are some people in law enforcement who would like to be a ghost participant on that conversation. Again, I am not saying that I do not support law enforcement, but it's a different use case. I am representing right now only the point of view of the brick and mortar enterprises. That is actually a much more solvable problem. The problem with the ISP and the problem with law enforcement are harder problems, and somebody else has to deal with those.
Continuing, I think since we are in India, I just wanted to also highlight that in 2017, in Justice K.S. Puttaswamy versus the Union of India, the right to privacy was upheld as a fundamental right. So I think in many countries this is upheld, and how does that, you know, play with this? Monitoring is a complex problem, and I know there are no easy solutions, but that's something to keep in mind, that some people value their privacy way over than the concerns of child pornography and terrorism. And I think, yeah, finding the right balance is always hard. But what might help is, like, so enterprises have this legitimate use case that they want to monitor, but it would help their case if they are more transparent about how they are using it, right? So I'm based out of Finland, and I'll give you an example of Finland. So in Finland we have this law that was passed in 2009, which is called Lex Nokia. So this was on demand from Nokia, that they want to snoop in on their employees and monitor their emails. So of course it's a socialist country. They had once the law was passed, they set up a data ombudsman to monitor how these enterprises were tracking their employees' emails. So since 2009, only 6 companies have made a request, and none of them have been from Nokia to monitor their employees. So the study found that only 6 companies in Finland tapped into their legal right to monitor employee email, including these 2 companies. And one of the things was that one of the reasons for Nokia's failure was it made the employees more fearful of their employer. So perhaps having this kind of ombudsman and then saying that, okay, we have this monitoring of our employees, and this is how many times we have used it, and this is how many insiders we have caught, would perhaps make people feel more comfortable about it.
Yeah, that's the whole thing. You know what? Okay, let me be the first to say I do not have all the answers to any of this, you know? I'm just bringing up a point of view and things that I know directly that are, you know, impacting people. These things are huge issues, but I think these are very important conversations. I think these are very important conversations that all of us should be having. So let's talk about insiders. attacks and insider threats and what happens. Okay, I deal with people on large networks every day, and like I know there's one company I deal with, and they clear every trade on all of our stock exchanges. I mean, they don't go home unless the stock exchange is closed. They stay there until it's closed. So I was talking to them the other day about something, and they have no rights to change anything on their PCs. They have no admin rights. In fact, right now, it's like they don't even have, I'm like, what kind of device do you even have? It doesn't even have a hard drive. I mean, it's like some virtual something or another that God knows even what it is. And we're just trying to do some network monitoring here. We're trying to read some packet traces. And they have no access, no rights to do anything, because people are so concerned about insider threats, and I'm going to blame some of the fear-mongering that some companies have done. I don't know what part of the problem is, I don't know what the truth is about how many insider attacks that there really are. But a lot of people are very afraid of insider attacks.
Edward Snowden was an insider attack, so that's a very good example of insider attacks that happen. But keeping track, like, okay, we monitor our employees, and over the past year we have captured so many packets, so many flows, and prevented so many insider attacks. Like, providing this visibility through a third-party data ombudsman would kind of help.
Yeah, no, I think, as I said, I think this stuff needs to be talked about. I mean, and I will tell you, I'll give you one. This is just one data point. But I remember I had a consulting gig with somebody, and it was like over the Christmas holidays. I was doing some performance enhancements for them and stuff. So I had a huge number of packet traces, and so I could see what sites all these people were going to, and it was fantasyfootball.com, coachfactoryoutlet.com. You know, I'm like, Jesus, why don't I have this job where it's like what I do during my work time? So a lot of people, in some ways you can be like I do think that people, if it's my point of view, if it's your work, they gave you that computer, they're actually paying you to do something ostensibly for them and not to be going to coachfactoryoutlet.com, I think you owe it to them to do that. So these are tricky questions. Yeah.
So now that we have IoT coming into the enterprise,
Yep.
and maybe not right now, but they also wanted to interact with the social media.
Oh, Jesus.
Right, you want your fire alarm to post on your Facebook. So in that scenario, OAuth, which is basically something that came out from the industry, I think personally is not suitable when it's deployed for an enterprise IoT kind of scenario. I mean, it doesn't really scale from authorization perspective, the human in the loop, and there's no concept of a shared concept of privacy, and so on and so forth. So do you think that the IETF will have to really rethink on that, or is there?
Yeah, these are all tricky questions. One thing I will tell you is, because of all this, we actually formed an industry consortium. And as I say, we had it as enterprise data center operators, but we're converting to a nonprofit consortium, Industry Network Technology Council, and we're getting a bunch of people that, actually longtime IETFers on the board of it, and to help talk to industry, because a lot of the people in industry, they don't even know what's going on. They're so busy trying to deal with day-to-day stuff. It's like, what do you look 5 years from now? I can't even do what I got to do today. But so I really would like to, at least our first attempt will be at least to educate them and start getting, stuff back, because I have talked to one of the large medical device manufacturers They have a lot of the stuff is IPv6 and all that. I mean, it's all IoT stuff, and they're very, very concerned about a lot of the stuff. And because that's one of the first things I know is really going out. And as I was saying, but if you guys are interested in our consortium, we're going to be doing a lot of educational and training stuff, totally free. Actually, Aaron is even funding us to do some IPv6 training. So just drop me an email, and I'll get you on the email list for that, and so you can listen to webcasts and stuff, or if you have other comments. Yeah, love to hear what questions you guys are anything you guys have. Thank you. Yeah, one more.
Madam, I have a very small question. I'm coming from an engineering college, and a lot of students are with me, and also in my college. One thing is that whatever we are talking about, very big thing and everything, sometimes it is beyond the scope of the students. What can we do? It will be diluted for the student in a nutshell, so that we can interface students so quickly in the engineering, in the beginners or budding time. Madam, please.
You mean, like say this in 3 words? Like, what's the problem?
One word, WhatsApp.
Life is
Just
hard.
one word. WhatsApp.
What's Deepak?
Because they are our future.
What's that? What are you thinking, Deepak? Is it WhatsApp is the problem?
No, not problem.
Or you can
I'm
see-
saying WhatsApp uses TLS 1.3 probably. So, in that sense. if it
WhatsApp
does-
uses TLS 1.3? No, TLS.
It uses a variant of Signal,
Okay.
not TLS.
Not TLS.
Yeah, it's
So it's related to MLS. which-
MLS, yeah. So anybody have any, like how to make the issue so that, is there an analogy somebody can do? I know what. It's like one analogy we used to use is like, it's like if you don't want to give your car keys to everybody, but if the mechanic has to fix your car, you have to give him your keys. Otherwise he can't fix your car. That's the problem, is the enterprises feel like it's my network. I own it. I built it. I'm the engine, and I maintain it, and I own the data. I want to see it, but you're making it so I can't see it. That's their point of view. So if that's a simple analogy. Yeah.
Thanks, ma'am.
Thank you.
Thank you, Nalini.